In this podcast, we're going to determine if intermediate value theorem can be applied and determine the values of c such that f of c equals k. So here's our function, x cubed minus 3x squared plus 3x. K is 9 and our intervals between 1 and 2. All right, we have to ask ourselves our 3 questions to solve. Question number 1, we have to determine continuity of our function on the interval. So polynomial functions are continuous everywhere. Therefore, they're going to be continuous on that closed interval. All right, so now we got to check and make sure that k is in between 9, right? Because nothing's guaranteed unless k is in between 9. So we find f of 1, right? And we get 1. We find f of 2, and we get 2. Uh-oh. Right, since 1 is less than 9, is not less than 2, f of a less than k less than f of b has not been met, and therefore intermediate value theorem does not apply. We are not guaranteed a c such that f of c equals k for values outside the interval f of a, f of b. All right, so since k is outside our interval, that's it. We're done with this one. No point, no solving if you don't meet the requirements. You stop as soon as you don't meet a requirement. But you continue if you meet all the requirements. Next one, determine if the intermediate value theorem can be applied and determine values of c such that f of c equals k. Our function is now tangent x. K is 1, our interval is 0 pi. Remember that tangent can also be written as sine x divided by cosine x. So we need to determine if f of x is continuous on the interval. Right, so tan x is equal to sine x divided by cosine x. Tangent x is undefined where cosine x is equal to 0. Since cosine pi halves is 0 is in the interval, tangent x is not continuous on 0 pi. It's got an asymptote. And intermediate value theorem does not apply. If your function is not continuous, you need to show why your function is not continuous and state that intermediate value theorem does not apply. And we're done with this one. So that's why I left these ones up. These were a little bit quick ones. I think they're in your notes. If they're not in your notes, make sure you pause the tape and write them in, okay? All of these ones. I may have put it in your notes because I didn't even erase it. And this one might be in your notes too. However, I mean, I'm sure the problem's in your notes. It may even be already written in there, but I decided I was going to do this one from start to finish, right? Because this one is a little more involved than our don't even meet the requirements problems. Just going to move that up a little bit. Oh, that's the top of my pie. All right, so determine if intermediate value theorem can be applied and determine values of c such that f of c equals k. All right, so first we need to address the continuity issue. All right, so, well, that's pretty easy to address, right? So, actually, I don't need to write a since. Sine x, so f of x equals sine x is continuous everywhere. If you've got one of those continuous everywhere functions, you can state it. So sine x is continuous everywhere. Therefore, it's got to be continuous on the closed interval too, huh? All right, so let's go to 2. I'm actually going to switch colors. We need to make sure that k is between f of a and f of b. And we'll do that by finding f of a and f of b. All right, so f of a, oops, I thought I changed that to green so I could have different colors. All right, there we go, 2. So f of a was 0, right? So f of 0 is sine 0, right, which is 0. All right, let's find f of pi halves. So f of pi halves, that would be sine pi halves. Remember what that would look like, right here. So this was 0, right? So I need to graph it, and this is pi halves right here. Every one of the pi halves is 90 degrees, so we're adding a half a pi halves every time we get to one of the axes. All right, so sine, of course, is opposite over trying to write hypotenuse. Now that looks close enough to hypotenuse. Opposite over hypotenuse, right? And the opposite is y. Of course, the hypotenuse is just whatever the hypotenuse happens to be. But if your y is 0, put an r. We usually abbreviate that r. If your y is 0, like right there, right? Well, then sine has got to be 0. Here, however, right, a y value is 1. Your hypotenuse is 1 as well, because your r is always 1 all the time, right? So now you've got 1 over 1, which is just 1. Right, so this is just equal to 1. And we're not to write it. I guess I'll put it over here. So f of pi halves equals 1. Right, so now have we met it? Well, yes, 1/2 is in between 0 and 1. Oops. Can't move that over. All right, so we have 0 and 1/2, and we have pi 1. Excuse me. Looking at the wrong thing. All right, so we've met that. So therefore, this is therefore. We did meet the requirement that K be between f of A and f of B. All right, so 2 out of 3 met. All right, so now we can go ahead and find C. All right, so now we're going to set our function equal to K. All right, so we have 1/2 equals sine x. So we're going to take the arc sine of both sides. Let me see if I can just move that over a little bit. It's a little busy over here. It says no. Ah, there we go. Good enough. All right, so we take the arc sine of both sides. So we have arc sine of 1/2 equals arc sine of sine x. Arc sine and sine cancel each other out, so that's just x. Now we have to take the arc sine of 1/2. All right, that means we have to solve for where sine x is equal to 1/2. The 1 is going to be the opposite side. The 2 is going to be the hypotenuse. Which one of our special right triangles is this? Of course, this is the 30, 60, 90. So when we're solving these, it's going to be, if it's going to be a pretty number, which these are most likely going to be, it's going to be one of 3 things. It's either a quad angle, in which case r is 1, and x, it's either going to be y or x, depending on if it's sine or cosine. But if we're solving for sine, right, it's going to be y, and it's going to oscillate between 0 and 1, right, the whole time. So on our quad angles. It's going to be either, or it could be a 30, 60, 90 triangle, or it could be a 45, 45, 90. In this case, this is the 30, 60, 90. There we go. All right, so if it's 1, 1 is opposite the 30-degree side, which is the same as pi 6. This would be the square root of 3. That's the same as pi thirds, and this would be the 2, which is the same as pi halves. All right, so that's going to be, right, 30 degrees. Of course, it's going to be the first quadrant. This is the 1 and 2. And this is right here. Our angle there is pi 6. We could also have it, the only other place where sine is going to be positive, over here. And 1 and 2. All right, so now, right here, that's pi. This is still pi 6. So to find this spot right here, which is that right there, we're going to take pi minus pi 6, which is 5 pi 6. And that, by the way, is our two answers here. All right, so x is going to be pi 6, or x equals, whoops, 5 pi 6. Did not mean to put that in the denominator. Are they both good? It's possible to have more than one c. Not in this case. This one right here is outside the interval. That is more than pi halves. But this one, ching ching, that is good. All right, so now let's just end our answer here. So, since f of x equals sine x is a continuous function, and it was, I'm just going to write, I'll write it this way this time. There it is. So f of a is less than k is less than f of b. Instead of as shown above, I'm just going to put since 0, sometimes I write it this way instead, 0 is less than 1/2 is less than 1. We are guaranteed to have at least one value c where f of c equals k, which, I'm going to make this one sentence, which is, and it was pi 6, since 0 is greater, is less than, pi 6 is less than pi halves. There we go. Very well stated here, every single part. All right, so not necessarily fast problems. We've got to solve a few steps here, but not difficult problems either. And they can be fast problems, as you saw in the last couple examples, where we didn't meet one of the requirements. Right? So, but make sure you meet the requirements. Make sure you document a very good example of what you should do. I don't remember if it's exactly the same way as the one I had here before, and the one that may be in your notes. I did not bring my notes with me when I came to make the podcast, but I don't really need them in front of me anyway. But either way, all the steps will have been stated. All right, so sample problems, prove that there's a number c such that c squared equals 2. All right, make sure, so just the moral here, we have good answers and bad answers. Mathematical arguments consist of complete sentences, not just formulas. All right, so some numbers and intermediate value theorem. Intermediate value theorem what? Yep, so this, bad answer. Bad answer. You're probably not going to get any points out of that. Good answer, okay? So make sure you document. All right, so now we're going to do two problems, I think it's two, that are word problems, and we have a table of values. Make sure when it tells you that f of g are continuous functions that you state it is given that f of g are continuous functions. All right, so the functions f and g are continuous for all real numbers. The table below shows given values of the functions at selected values of x. The function h is given by h of x equals g of f of x plus 2. So evaluating a composite function, and if it's inside out, you substitute x into the inside function, substitute the result into the outside function. That's not intermediate value theorem. That's just evaluating a composite function that I'm afraid you might have forgotten. All right, so explain why there must be at least, must be a value w for 1 less than w less than 5 such that h of w equals 0. All right, so we're still going to follow all of our steps, right, but now we just have a table of values and we have a composite function. All right, so first of all, do we have a continuous function? It is given that f and g are continuous functions, but that's not enough. So if I didn't state the next thing, make sure it's in your notes. I think it's probably blank in your notes, although I know this example is in your notes. All right, that's not enough. Remember, we had one of the things we learned about when we were studying continuity is that and composite functions, actually I'm going to put composites. Composites of continuous functions are also continuous. So you got to state that too. We got to show not only are the functions continuous that we were given, so is the composition. Composites of continuous functions are continuous. There we go. So we got step 1. All right, step 2. We need to evaluate for 1 and 5, right? And make sure that 0 is between f of 1 and f of 5. Right? So k here is 0, right? That's our 0. H of w h of w is equals to 0. That's what we're interested in here. All right, so now let's find h of 1, and well, I need to find also, of course, g of 1, h of 1 and h of 5. All right, so to find h of 1, right, we're going to need to find, and it's g of f of x, g of f of, let me write it down here so I don't have to keep looking up above. So h of x is g of f of x plus 2. Oh, I'm missing a parenthesis there. Plus 2. All right, so we need to find, first of all, h of 1, which is going to be g of f of 1 plus 2. And I'm going to go this way so I have some space to write later on. So h of 1, I'm going to plug in to f. All right, so f of 1 is 3, right? If I plug 1 into f of x, I get 3. Right, so that's g of 3 plus 2. What's g of 3? I'm going to switch colors here. So g of 3 is right there, is negative 10. So h of 1 is negative 10 plus 2, and therefore, I wish I had just a teeny wee bit of more room. Move it over a little bit. There we go. Squeeze the last little thing. H of 1 equals negative 8, right? So you got to go inside, right, and evaluate, and take that value and plug that into G. So it's going to got to plug in the x value for x, then find f of x, whatever that is, plug that in for G. Once you get that value, you just add 2 to it. All right, so now let's find h of 5. So that's going to be g of f of 5 plus 2, which is h of 5 is going to be g of, right, so we got f of 5, so f of 5 is 7, right, so we got g of 7 plus 2, right, so now we're going to plug 7 into g, right, so that's going to give us 25. Right, so h of 5 is 25 plus 2. So h of 5 is 27. All right, so let's look at our directions here. Explain why there must be a value. Didn't ask us to find that value. We just have to explain why there must be a value. And we're going to do that right now. All right, so since h of x is the composite, I always sum everything up after I've answered it, then nobody could possibly miss that you've stated everything. All right, so since, and it's a good way to end your, when you've got to explain something. Anytime you've got to explain anything in math. So since h of x is the composite of continuous functions, and is therefore continuous, and f of 1 is less than, where is, oh, that's right, k was 0. K and is less than f of 5, since, so we have f of 1 there was -8, k there was 0, and h is 27. And we're asked to find, there must be a value. Okay? There must be a value C. Oh, I'm surprised I didn't expand. Such that f of C equals k according to intermediate value theorem. By the way, if the answer was already in your notes, I don't always say things exactly the same way, but I have the exact same meaning. All right, so here we did a problem using a table of values and a composite function. This is a very common problem in AP. I guarantee you somewhere there'll be a composite function. It may not be for intermediate value theorem, but it could very well be. I've seen one in the last couple of years. All right, so here, so since h of x is a composite of continuous functions and is therefore continuous, and k is f of 1 is less than k is less than f of 5, since -8 is less than 0 is less than 27, there must be a value c such that f of c equals k according to intermediate value theorem. Okay, there we've got it. I think I have one more like this, right? I think that's the last one. And, am I right? Oh, no, I have two more problems, but one of them is multiple choice, and then that's the last one. And I'll be posting your closings when we're back in school, right? So I don't have closings over break. So the video was made over break. In future years, it may not be watched over break. A toy car travels on a straight path. During the time interval between 0 and 60 seconds, the toy car's velocity, v, measured in feet per second, is a continuous function. Underline it when you see continuous function. Selected values are given below. For t between 0 and 60, must there be a time when v of t equals -2? Justify. All right? Right away, when you see something like this, continuous function, you're looking for a value in between such that, right? So you've got a closed interval. You have a continuous function. You're finding C such that f of c equals k. you want to think, waiting for my words to come up, think intermediate value theorem, right? All right, so it means you've got to meet the requirements for intermediate value theorem. So number one, we have to determine if this is a continuous function. And we can say it is given. It is given. And state what is given. It is given that, and we can call it v of t. It says got v of t right there. Don't call it f of x. Right? This is not f of x. Make sure you call it by the right name. Okay? Calling it v of t is fine. Right? So it is given. I'm actually write that in. Make sure you call functions by their right names. You call functions by their given name. All right, don't change their names. All right, it's given that v of t is a continuous function. State it's a closed interval. Right, it's continuous on a closed interval. Continuous function. For our polynomial functions later on, we showed it was a continuous interval, a closed interval. But it's given that v of t is a continuous function on so 0 to 60. All right, there we've taken care of requirement number one. We're on to requirement number two. All right, so we need to find our starting and ending values. Of course, we've got 0 as our start and 60 as our end. So we need to make sure that k is in between those. All right, so we got to find f of, after I said make sure you call them by their names, it's v. v of 0, all right, and so that's going to be negative 10. It's right there. Much like v of 60 is 13. Right, so since, and our k is negative 2, right? So since v, got used to, v of a is less than k is less than, and I probably should say, instead of k though, I'm going to say v of t since it specifically says v of t. All right, so since v of a is less than v of t, or actually let me get rid of this since. So as soon as I have to make sure my sentences are sentences. I've got the thoughts in my head and make sure there's a sentence. All right, so we have v of a is less than v of t is less than v of b since so it was 0, it was negative 10. Since negative 10 is less than negative 2 is less than 13. All right, so we have met requirement number 2. We've shown k is in between, right, our f of a, and in this case our v of a and v of b. All right, we have one last thing to do. This time we're not solving for c, right? It doesn't ask us, right? It says must there be a time? Didn't ask us what that time is, right? And actually, you'd be hard pressed to find what that time is. But we can know that there is a time, right? So since v of t is a continuous function on the closed interval, and v of a I think it's going to be a run-on sentence, but that's okay. V of a is less than v of t is less than B of B and I'll just use our numbers. Negative 10 is less than negative 2 is less than 13. According, I'll put the IVT first this time. According to intermediate value theorem, which is fine to abbreviate, actually, instead of there must, I'm going to put we are guaranteed. Since we, actually they put there must. Must there be a time? Okay, I'm going to put there must instead. There must be a time when V of t equals negative 2. There we go. All right, so we showed it's continuous. You've got to state that. You've got to show that k is in between f of a and f of b, or v of a and v of b, or whatever letter happens to be. All right, and then you got to explain your answer. If you're asked to find c, you got to find c, and then you got to explain your answer. All right, we weren't asked to find c, and we can't, but we can explain that at some point the velocity has to be negative 2. You can't go from negative 10 to 13 without at some point being at negative 2. And here we can show that using intermediate values theorem, right? We've got to be able to show the things that we say are really true. Last question. Let g of x be a continuous function. Selected values of g are given in the table below. What is the fewest number of times the graph of g of x will intersect y equals 1 on the closed interval 310? All right, so now we're not looking for positive, negative. We're looking for, did you cross 1? All right, so let's see. Between 2 and 5. All right, so well, x is 3 and 5, but the value of the function is 2 and 5. There's no 1, right? We did not cross 1. I'll actually put in no y equals 1. I almost made this a question for you. I decided I'd make it a question for us. All right, so there's no y equals 1. Oh, but here you go between 5 and negative 1. So yes, right? We do have 1 is in between negative 1 and 5 there. So there's 1. All right, so this one was a no. This one is a yes. How about the next one? Oh, that's a yes. All right, because negative, so 1 there is in between negative 1 and 4. All right, how about the next one? That's got to be a yes as well, right? Because 1 is between 0 and 4. So you're looking anytime you went past 1 along the way to the next y value, you have to cross 1 because this is a continuous function. All right, so we had 3 yeses, and 3 is the answer. All right, so let's write them into. So yes, it's 3, and it's between x equals, actually I'm just going to write the as an interval notation. So between 5 and 6, and then again between 6 and 9, and finally one more time between 9 and 10. And there we go. All right, so intermediate value theorem, a way to find the existence of zeros and other values where you have a continuous function and you've crossed from one point to another. Thanks for watching. Bye for now.